Hello and welcome to 11.1 Parametrization of Plane Curves. So with this chapter we start off with a section on parametric equations. Basically, parametric equations, you want to think of you have your coordinate plane, your x and y, but now you're adding a dimension of time. So when we start drawing these curves, we think of it like it's a particle that's moving along this curve, and we're tracking the time and the position movement of that particle. Okay, so this is the definition of it. We have x defined as a function of time, and we have y defined as a function of time. Okay, and then we get to see what the graphs of these look like. Okay. So let's start out with our first example. We have x equal to t plus 2 and y equal to t squared. We want to sketch the curve defined by these parametric equations. And we notice that t is going to be between -2 and +2. Okay, so the best way to do this is to make a table. We can make a table of t, x, and y. Now, because t has to be between -2 and 2, that's going to be the variable that controls everything. So we have -2 to 2, so -2, -1, 0, 1, and 2. And so now let's start coming up with x values. We plug in -2 for t, so -2 plus 2 would be 0. And then -1, -1 plus 2 would be 1. 0, 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. Now let's come up with the y variables, the y values. Plug in -2 for t in the y equation. So -2 squared would be a +4. -1 squared will be +1. 0 squared will be 0. 1 squared will be 1. And 2 squared will be 4. Okay, so now let's graph these. Okay, so when we graph it, keep in mind that we are graphing the x and the y's. Okay, so we're still graphing these. Okay, so first point is 0, 4, so we go to 0, 4. Next we have 1, 1, 2, 0, 3, 1, and 4, 4. Okay, so this will be the graph. Okay, and we want to track the movement of the particle, if you will. So the first t value was -2. So at -2 it was 0, 4. So this was like our starting point at 0, 4. So this was when t was equal to -2. Then we went to t equals -1. And then we went to t equals 0, t equals 1, t equals 2. So it went this way. Okay, and a lot of times you will see these arrow marks to show the direction of the movement for the particle. Okay, let's take a look at our next example. Okay, x equals square root of t and y equals 2t plus 1. T has to be greater than or equal to 0. Okay, so let's make a table again of t, x, and y greater than or equal to 0. So now I'm going to choose my t's, carefully, greater than or equal to 0, because I'm looking at the x's, right? And x, I'm taking the square root of t. So I want to choose t's that I could easily take the square root of. Okay, so I could do 0, I could do 1, but after that I'm going to go to 4, right? Numbers that I could easily take the square root of. Okay, and then let's see, I'll go from there. So if I plug in 0 for t, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, for my y is 2t plus 1. So I'm plugging in t again. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 4 is 8, plus 1 is 9. And 2 times 9 is 18, plus 1, 19. Okay, so let's sketch the graph of this. So sketching the graph. Okay, so again, keep in mind we're graphing the x's and the y's. Okay, so we have 0, 1. So 0, 1. 1, 3. 2, 9. Let me see where this is going. 3, 19 will probably be like up here. Okay, so we have our t equals 0. Right, t equals 0 at here. This one will be t equals 1. T equals 4. And the one up here is t equals 9. So we see the movement of the particle going in that direction. Okay. Sketch the curve defined by the parametric equations. Okay, so we have x equals sine of pi t over 2, y equals t, and t is between 0 and 6. Okay, let's make a table. T, x, y. So t is between 0 and 6, so let's go 0, 1, 2, 3, 4, 5, 6. Okay, let's first plug in for t in our x equation. Okay, so that means, what do we have when when t is 0, 0 times pi is 0, right? So sine of 0 will be 0. And then y is t, so y is 0. Okay. All right, next, when t is 1, we have sine of pi over 2. That's sine of 90, so sine of 90 is 1. And then y is 1. When t is 2, we have sine of 90 times 2, so that's 2 pi. Sine of 2 pi over 2, what will that be? Well, sine of 2 pi is 0, right? 0 over 0, 0 over 2, 0. Okay, and that means the y would be, y is equal to t, so y is 2. Okay, 3. In 3, we have sine of 3 pi. Sine of 3 pi over 2. Sine of 3 pi over 2, that's 270, so that's negative 1. And the y is equal to 3. Sine of 4 pi over 2. Well, that would be just sine of 2 pi, which is 0. Y is 4. Sine of 5 pi over 2, that will be 1. Y is 5. And for 6, sine of 6 pi over 2, that will be 0. And so we end up with 6. Okay, so let's graph these. Okay, so we have 0, 0, 1, 1, 0, 2, negative 1, 3, 0, 4, 1, 5, and 0, 6. Okay, so we kind of have this motion going on. Okay, when t is equal to 0, we're here. When t is equal to 1, we're here. When t is equal to 2, we're there. When t is equal to 3, when t is equal to 4, t is equal to 5, and t is equal to 6. So we're going like this. And that's the motion of it. Okay. Alright, sketch the curve defined by the parametric equations. X equals t squared, y equals t plus 1, and t is between negative infinity and infinity. So again, let's make a table of values with t, x, and y. We're going to start somewhere. I'll go with negative. So negative 2, negative 1, 0, 1, and 2. Okay, so if I do negative 2, I plug it in here, I square it, I get 4. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. For the y's, okay, I'm plugging into the second equation. Negative 2 plus 1 is negative 1. Then I have negative 1 plus 1, which is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Alright, so let's graph this, see what it looks like. Again, remember we're graphing the x comma y's. Okay, so alright, so we have 4, negative 1. 4, negative 1 will be like right here. Then we have 1, 0. 1, 0. 0, 1. 1, 2. And 4, 3. So we have a graph. Okay, so according to this, my t equals -2 is here, and t equals -1, t equals 0, t equals 1, and t equals 2. So it's going in this direction. Okay. One subtle thing to note for this one, because t is really all real numbers, right? This doesn't have a starting point or an ending point. Notice we could have gone back with t as far as we wanted to in the negatives, and we could have kept going forward to the positives as much as we want, but it would have no starting point or ending point. Okay, so let's take a look at next one. X equals cosine of t, y equals sine of t, and t is between 0 and 2 pi. Okay, so sometimes we'll see this. What we do know from earlier in our math careers, we have a trig identity tying together cosine and sine, right? And that trig identity is cosine squared plus sine squared equals 1. Okay, so our cosine here is x, so we have x squared, and our sine here is y, so we have y squared. So this is basically our circle equation, right? We have a circle equation whenever it's like this. This would be a circle centered at the origin, and whatever the radius is, this would happen to be the unit circle. Right, this would be the unit circle, so we would have like that. Now to figure out the direction, obviously then we would make a table. So let's make a table. We have t, x, y. You want to pick your classic values here between 0 and 2 pi. That relates the sine and the cosine. So we would start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so when t is 0, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. Okay, for the y's, now we plug into the sine. Sine of 0, 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. Okay, so when t is 0, we are at 1, 0. So we're right here at t equals 0. When t equals pi over 2, we're at 0, 1. Right, again, we're looking at our x, y's. So 0, 1, so that's t equals pi over 2. Then we go to t equals pi. So we're going in the counterclockwise direction. T equals 3 pi over 2. And then finally we're back to t equals 0, which is the same as t equals 2 pi. Okay, take a look at our next one. X equals sine of t, y equals 2, x equals 2 sine t, y equals 2 cosine t, and t is between 0 and 2 pi. Okay, so we want to be able to use our identity, right? We want to be able to say sine squared of t plus cosine squared of t equals 1. So that means we should try to get these in sine t, solve it for sine t, solve this for cosine t. Right? If I solve my x equals 2 sine t, that means I would divide both sides by 2. So my sine t would equal x over 2. Okay, so keep that in mind. Sine t would equal x over 2. For my cosine, if I want to get the cosine, I would divide both sides by 2. So I would have cosine t equals y over 2. Okay, so that means I could set this up and put x over 2 squared plus y over 2 squared equals 1. And that means I would have, if I square these, x squared over 4 plus y squared over 4 equals 1. Okay, now if I multiply both sides by 4, that means the 4's would cancel here, and I would be left with x squared plus y squared equals 4. So again, this would be my circle centered at the origin. My r squared would be 4, so my radius then would be 2. Okay, so I would graph this. Centers at the origin, so I have a radius of 2, so I'll go 2 in each direction. Something like that. Not perfect, but something like that. Okay, so to figure out the movement of the particle, let's make a table. T, X, Y. So I'll do my classic from 0 to 2 pi. I'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, plug in 0. So I'm plugging into my original equations. Okay, so I have x is 2 times sine of 0. Well, sine of 0 is 0, so I have 0. Sine of 90 is 1. 2 times that would be 2. Sine of pi is 0. Sine of 3 pi over 2 is negative 1 times 2, negative 2. And sine of 2 pi is 0. Okay, for my y's, y is equal to 2 cosine t. So that means when cosine of 0 is 1 times 2, be 2. Cosine of 90 is 0. Cosine of pi is negative 1 times the 2 would be negative 2. Cosine of 270 would be 0. And cosine of 2 pi would be 1 times 2 would be that. Okay, so at time equals 0, I am at 0, 2. Okay, so I start off at 0, 2, then I go to 2, 0. Let's see where that is. 0, 2, Okay, so 0, 2. Then I'm going to go to 2, 0. Then I have 0, negative 2. And then negative 2, 0. And then back to t equals 2 pi. Okay, so notice this one has a clockwise rotation. Okay. Okay, this one you guys could work on it on your own. This is similar to the other unit circle we did, where x equals cosine t and y equals sine t. Okay, just notice the difference between that one and the one we just did. Let's take a look at this one. This one's a little different coefficients. So if we solve for cosine, I'll divide by 4 here. If I solve for sine, divide by 7 here. So I have cosine of t equals x over 4. Sine of t equals y over 7. And again, I'm using my cosine squared t plus sine squared t equals 1 identity. So that means I'll have x over 4 squared plus y over 7 squared equals 1. That means I'll have x squared over 16 plus y squared over 49 equals 1. Okay, so that means this is not a circle, right? When it's in this form, this is an ellipse, right? This is an ellipse. This is an ellipse, and we'll have this one be, let's see, this is of the form. Remember, in an ellipse, you have to figure out a squared and b squared, the denominators. And a squared is always got to be the bigger one of the two, right? Whichever one's bigger, that's your a squared. So that means the 49 is the a squared, 16 is the b squared. So whenever it's of this form, that means this is an ellipse that's in a vertical orientation. Okay, if the a squared was under the x squared, then it would have been a horizontal orientation. Okay, so yeah, this is going to be a vertical orientation. Okay, and then we could easily graph this. We'll have t, x, and y. Again, it's between 0 and 2 pi, so we have 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so when t is 0, and we're going back into these equations, when t is 0, cosine is 1 times 4, so we get 4. Cosine of 90 is 0, so this is 0. Cosine of pi is negative 1, so this becomes negative 4. Cosine of 270 is 0, and cosine of 2 pi is 1 times 4. Okay, when t is 0, plug it into the y equation. So that means sine of 0 is 0. Sine of 90 is 1 times 7 is 7. Sine of pi is 0. Sine of 270 is -1, so that becomes -7. And sine of 2 pi is 0. Okay, so we got this. Okay, so when t is 0, we're at 4, 0. Then we have as t equals 0. When t is pi over 2, this is 0, 7. Okay, so we have 0, 7. Then we have -4, 0. Then we have 0, -7. So we're going to go like this. In direction. Like that. Okay, so that's it for this first half. I'll continue with a shorter video later on. I don't want the video to be too long, but I'll see you guys soon.